All right, today we're going to start talking about related rates. In calculus, we often have equations with two or more variables that satisfy some relationship over some interval of time. We usually have some knowledge of the rate of change of one or more of these variables with respect to time and wish to find the rate of change with respect to time of the other variable. These are called related rate problems. So before we dive into the word problem, like word heavy related rate problems, we're going to look at an equation here. Number one, it says two variables x and y are functions of a variable t and are related by the equation x cubed minus 2y squared plus 5x equals 16. It tells us the change in x with respect to time, so dx dt, is 4 when x equals 2 and y equals negative 1. We want to find dy dt, that's the change in y with respect to time. So what we're going to do to this equation is take the derivative of both sides with respect to t. So this ties in with what we just did recently with implicit differentiation, except here we're doing it in terms of t. So none of these variables in here are t. So we're going to go ahead, every time we take the derivative of one of these variables, we also have to multiply by the derivative of the variable with respect to time, just like we did with dy dx in the earlier problems. So for our first one here, we end up with 3x squared times derivative of x with respect to time. Since these variables don't match up, since this is in terms of time and this is an x, we have to multiply by dx dt. Minus 4y to the first times dy dt. Plus 5 times the derivative of x, which is dx dt. And the derivative of 16 is just 0. So with this now, we have some given information that we can use to figure out what dy dt is. So we're going to use these values and substitute them in. So we're going to substitute the x equals 2, the y equals negative 1, and the dx dt equals 4 into this equation. So we end up with 3 times x is 2 squared times dx dt is 4 minus 4 times negative 1 times dy dt, that's what we're trying to figure out, plus 5 times dx dt, which is 4, and that's equal to 0. So now we have to solve this for dy dt. So here we have 3 times 4 times 4, so we get 48. Here we have plus 4 dy dt plus 20 equals 0. So we can combine these, we get 68. Move that to the other side, we get 4 dy dt equals negative 68. Divide both sides by 4, and dy dt is negative 17. So the change in y with respect to time is negative 17.